Alright, so today our topic is Unit 2.1, Day 4, and what we're going to be doing is we're going to be finding zeros of a quadratic function. Now we've already kind of talked about zeros a little bit. Now there's several names that we can use for zeros. One of those things that we used were solutions, and that's kind of what we're going to be playing with today. We also know these as x-intercepts too as well. And the last one was we also know these as factors. So we had four names that we could use for these, and so this is going to be kind of the essence of finding zeros of a quadratic function and kind of what they mean to us. And so our objective over the next couple days of what we're going to be working with as far as finding the zeros is that we're going to factor quadratic equations to use the quadratic formula to find our solutions. What we're going to be focused on in this video is factoring the quadratic equations. Second thing that we're going to be focusing on today is graphing quadratic functions to find the zeros. So there's three ways that we're going to basically do this, and we're going to focus on two today. We're also going to determine intervals where the function is increasing or decreasing and determine end behavior. So what we're going to look at is we're going to look at how this function behaves, how it works, and whether it's increasing, decreasing, and what our end behavior is. And again, end behavior is something that we did in Unit 1 where we talked about end behavior. Alright, so if you could go ahead and copy down these particular things, we're going to be going over these. This is going to be kind of the focus of our discussion today, are identifying some of these key features of a quadratic. So I have two different quadratics that are graphed here. I have one that's positive and it's f of x is x squared, and the one at the bottom is kind of a little bit different. This is in our vertex form. And the idea here is that we have it going down, so this is our negative value. So a couple of things, if we look at some of our key terms here, the highest point on the graph, or the greatest value, this is what we would call our maximum. And so the maximum is the highest point, and when we talk about greatest value, we're always talking about the y value. We want to know what it equates to. So instead of using the x values to say, oh, well, at this value it's a certain amount, well, we want to know what the y value is. So is the greatest value 6? Is the greatest value 27? Not necessarily where it is on the x-axis. The lowest point is going to be our minimum. And it's kind of the same idea. Instead of looking at the smallest value or the least value, we're always looking at the y. So what does y equal to give us that minimum value? And most of the time we're going to get these two things, and I can put a little arrow here. We're going to get these from the vertex. So whenever we're looking for minimum or maximum, we're always kind of looking for that vertex. So remember how we can find that vertex. The next one is that it's a point at which the function intersects the x-axis. Now, most of us will call this an x-intercept because that's where it intersects the x-axis. But what we're going to want to know this as is we're going to want to know this as a 0. This is where our graph is equal to 0. So when we talk about this maximum and minimum value, and we talk about the y value, that means y is equal to 0. So what value of x will make our function 0? And if we look at that, we can identify those values. So here is where it's a 0, here is where it's a 0. So not only are these the x-intercepts, but these are also the zeros. It's where that function is equal to 0. That's what, if we plug in some value of x, here the value of the 0 is positive 1, so when x equals 1, and over here x is equal to negative 3. If I plug those two values in, I get a y value that's equal to 0. And we can also call these our solutions. And we'll talk about those and why they're solutions in just a little bit. Now the idea is that we kind of know this one. This would be our y-intercept, is the point at which our function intersects the y-axis. So in both of these equations we can label these. Here it's y equals 3. Here it's y equals 0 would be our intercept. Now the next one that we have is the directions the arms are extending as x goes to positive infinity and as x goes to negative infinity. We know that as end behavior. So what's the end behavior? Now we talked about this being even polynomials, and we talked about them either being positive or negative leading coefficient. So we can either know that they're going to both be pointing up or they're both going to be pointing down, depending on what that leading coefficient is. At the graph at the top, the leading coefficient there is positive, so they're both pointing up. And so that's my end behavior is up and up. Now if I look at the one at the bottom, my end behavior is down and down because that's a negative leading coefficient. Doesn't really matter what it is or where it's at, we just know that that's there. The last thing is that we want to talk about where this is increasing or decreasing. When we talk about increasing or decreasing, and we'll go to this in depth in the next video, but we're always going from left to right. So whenever we read a graph, we don't read it wherever we want to and kind of look at what it's doing. We always read it from left to right. So we start up in here in the top one, and we'll move this direction. And we can talk about whether that's going up or whether that's going down. And as we go here, we can talk about whether it's going up or whether it's going down. And we always talk about what the y value is doing. But what we do is we use an interval of x. So this is the only situation where we'll actually be using x. We want to know from what value. So if we start over here at like -7, as we go from -7 all the way to infinity or positive infinity, we want to know what our function is going to be doing at particular locations. So we'll talk about that again in our next video. So these are the key features of our quadratic, and these are kind of the interest points that we're going to be going over in class. So as I mentioned, there are 3 different ways that we can find zeros, or we can find what we call solutions. And so when we look at our quadratics, if we want to solve a quadratic, if we want to find the zeros, these are going to be important pieces of information for us. You know, we can find the vertex really easily from our equation. You know, we can look at what it is. Now the easiest method in anything typically is graphing. If I ask you to find the vertex of a graph, you can go and find the ordered pair. If I ask you to find the zeros of a function and I ask you to graph it, that's really all that we're doing. We're just finding the x-intercepts. So, you know, find those ordered pairs. Maybe there's 1, maybe there's 2. So if we look at this graph here, this is the same graph that I used before in the other part here, is that look at where x is, where the function will equal 0. So where does the graph cross the x-axis? And so here we have at x equals 1, and then over here we have x equals -3. Now if I was to write those as a solution, if I was to actually write those out, this would be -3, 0 and +1, 0. Now the idea behind that is we're just looking for those values. Now in a lot of cases when we're graphing, these are going to be estimates. We're not going to necessarily find anything perfect, and that's kind of the whole idea of graphing, is to find an estimation of what those zeros might be. Maybe you can see that the graph goes through it really easily, but at least identify it to a half or to a quarter, so that you can get at least a good idea of what those values might be. Now in a calculator, we'll go over this in class, but the idea is we can also do this on our calculators. We can graph the function that we normally do, and then we can go through this 3-step process and find a left and a right boundary. This was similar to the idea when we found our maximums and minimums. And we can make a left and a right boundary, and you can find those zeros pretty easily. So the idea there is that that's the information for graphing, and we can kind of just use that to go forward with this. Now our second way that's a little bit more accurate and sometimes a little bit more straightforward to find our zeros, or to find what we know as our solutions, would be to factor. Now we've factored already, so we kind of have the basics of factoring. And so in order to factor, to solve these quadratics, is that it's a similar situation that we did right before the end of the trimester, and as we started this trimester, we set our equation equal to 0. We wanted to know what those values of x that we were going to use are going to be. And so the most important thing is that we always set our equation equal to 0. In order to find solutions, we have to have some kind of true statement to set it up with, and that's why we set it equal to 0. And so when we're usually given these informations, we always get everything on one side. So if you notice, everything over here is on one side. And then I'm going to factor the quadratic. Remember, we have kind of our 2 binomial factors that we'll always get out of a quadratic if there is no common factor, so always remember to look for that too as well. and we're going to get a plus or minus b or x plus or minus a and x plus or minus b, where a and b would be two different numbers, but it doesn't necessarily have to be plus and minus. It would be either x plus a, x minus a, and then kind of the same thing with b. Now we're going to just use our basic factoring method when a is 1, so we're just going to find factor pairs. Or if a is not equal to 1, then we would use the a times c method and regroup. And if you wanted to, we have those previous videos up on this channel too as well. So the idea here is that we have x squared plus 5x plus 6, and so the idea is this coefficient is 1, so I'm going to see if I can find factor pairs of 6. That would end up giving me positive 5. And so the idea there is that we have factor pairs of 6, so we would have, these need to be negative, so maybe we have 1 and 6, maybe we have 2 and 3. So the idea behind here is that we would have negative 1 and positive 6 would be our two factors, and so then I can plug those right into my binomials, and then I would get x minus 1, x plus 6, and so that would give me, my factor. Now remember, this is equal to 0, and so the idea, what values could I plug in for x that would make this entire equation 0? Now this is the same thing that we did before in our first try, and we found the zeros, or we found anything like that, where x would equal 1, positive 1, and x would equal negative 6 if we tried to find the kind of the opposite there. And so here, these would be our two x-intercepts, or these would be our solutions to our quadratic. So what that means is that I know that I have x-intercepts at 1, 0 and negative 6, 0. And if I was to graph that, I would see that very easily. And so that's kind of the idea of factoring in order to find our zeros. Now in another situation, what we have is we have something that we need to set equal to 0, so don't forget how we go about this as far as setting this equal to 0. Now I told you I like this leading coefficient, this is a 2 with the x squared. I like that leading coefficient to be positive, and so I'm going to move everything over with that instead of moving the 2x squared, which would be easier, but again, I don't like to work with negative leading coefficients. And so the idea is I'm going to subtract 3x from both sides, and I get 2x squared minus 3x equaling 5, and then I would subtract 5 from both sides, and I would get 2x squared minus 3x minus 5 equaling 0. Now I go through the same thing. This time I don't have a coefficient of 1, and so I would need to do a times c, which would give me negative 10. And so from that, I can find factor pairs of negative 10 that give me negative 3, which would be negative 5 times positive 2. And then I go through my regrouping process. So 2x squared, and I'm going to go minus 5x plus 2x minus 5. And then I can go through and I can regroup these. Now if you notice, we find greatest common factors again. So x times 2x minus 5, so x would be the greatest common factor, plus 1. Since they don't have a common factor, it would always be a 1, 2x minus 5. And then I go through this again. My greatest common factor is 2x minus, not 2x, sorry, 2x minus 5 in parentheses times x plus 1. So in a situation like this, I have my two zeros, or that I would know that this is equal to 0. And so I would have to make sure that I find my two zeros. And so the first one, x plus 1 equals 0, that would give me a 0 of x equals negative 1. And then here, 2x minus 5 equals 0. I would have to solve that two-step equation, but I end up getting x equals 5 over 2. And so the idea there is those are my two zeros, so if I was to write those out, I would get negative 1, 0, and 5 over 2, 0 would be my two zeros. So in that situation, I just need to go through a couple other steps in order to find my zeros, but as of right now, that's pretty straightforward to find my zeros. Now in some situations, what we're going to find out is that's not the easiest way, or there might be an issue with doing that. So let's take a look at our last example. So our third way to find zeros is using what we call our quadratic formula. And so if we look at why we would want to use our quadratic formula, is that if I set this equal to 0, I have 5x squared plus 23x, and then I would add 36 to both sides, I would get this. I get 5x squared plus 23x plus 36. And if I was to use my A times C method in order to factor this, I would get 5 times 36, which would give me 180. And so I would have to find factor pairs of 180 that might give me 23. Now, in a situation like this, what we're going to find out is that may or may not be even possible. And so, we might not be able to get those particular factors to work out for us. And so in this situation, using our factoring method is too much work, and it's going to take way too long. Now, I could go through this and try to find those different factor pairs that might give me positive 23 or any situation like that, but it's going to not be worth my time. And so what I can do is I can just basically set this equal to 0, identify my A, B, and C. Now that A, B, and C is just like in our standard form. So it would be ax squared plus bx plus c equaling 0. So I would still find my A, B, and C that same way. But I would use my quadratic formula, which is the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. Now this seems like a very difficult formula, and we're going to be going over this in the next video, but the idea is we just plug in those numbers and we get an answer out of that. So if we kind of go back and we kind of look at what we were doing, we were simply just finding zeros. And so when we found zeros, we could either graph and we could find the x-intercepts, or we could factor our quadratic, so factor quadratics, and find solutions. So we found the zeros. So the idea is that we have two options that we're going to be working on. We're going to be working on the graphing, and we're going to be working on the factoring. And then we can work on identifying intervals of increasing and decreasing and using our quadratic formula. And so that's going to be it for this section of the video.